what is the matter universe made of? What is the stuff, this ocean that we're all in, this ocean of what seems like invisible matter? Now, it's really just stuff, just lumps of little stuff. And as a result, if you even look at like a teeny tiny electron, and that thing is just a lump of stuff, made of smaller pieces, of course, just as any larger pieces are, but it's just a lump of stuff. The same stuff that the whole matter universe is made of. Sometimes you hear about people talking about dark matter or dark energy or something like that. It's really just the push of the stuff that we don't see. And this stuff is the stuff that, all things are made of, all physical things, that is. From the dirt, from the stuff you don't see, the stuff you do see, it's all just stuff. I could call it matter or whatever I want to call it, but it doesn't really matter what you call it. It matters what it is. So since an electron is just stuff, here you have two electrons. They're right close to each other. And of course, these are just beads, but you can probably see there, two beads. Now, these beads represent not just the electron, but the stuff that's around the electron, like a buffer around the electron. Because the electron also, like, for example, when I explained gravity, the electron also has stuff around it that's attracted to the electron. So this is the electron plus the stuff that's around the electron. As you can see, two beads, two electrons, one electron, two electrons. Okay, now that's the first layer of an atom maxed out. So there's, the nucleus is in there, and then the electron and the stuff that's around the electron. There it is, the first layer, 2. The next layer of an atom, if it was maxed out, is 8. And as you can see, again, it's just a game of electrons filling holes. You can see for every hole, see, with this one you have this in the center with the 2 electrons. But the next layer out, if you fill all the holes, you get 8 electrons filling all the holes. That's the next layer out in the atom. Now what's next? Well, if you take all of these holes, all these cracks, and put more beads around them, that is more electrons with their buffers, you will get the next layer. That's a lot of holes filled, but as you can see, it's just lumps of stuff clumped together, just like anything else in the matter universe. But this is representative of electrons around an atom. This is the next layer maxed out, according to like the periodic table. Here you've got the next layer. Now, how many yellow beads are there? It's maxed out of the next layer. 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side. So, and 9 on this side equals 18. So you got this layer of 18 electrons for the third layer out. So what's next? The next, if you do the exact same thing, you'll find, from this, fill all the holes here, and you will get the next layer out. You see how the green beads have filled all the cracks that were in the yellow beads. And now this layer is maxed out. Now we have, in this layer we had 1, 2, 3 layers. This is the 4th layer maxed out. And again, it's just a game of filling holes. Just like everything in the whole matter universe is a game of filling holes. Just like every force and perceived property of matter is just matter filling holes. It's all just a big game of filling holes. So, here in this layer we have 1, 2, 3, 4 electrons here with their buffers. 4 times 4 is 16. 16 on the top, 16 on the bottom is 32. This layer is filled out because it has 32 electrons. This not only occurs with electrons, but filling spaces around atoms, but it also occurs with atoms in crystal structures, and you'll see the same kind of pattern existing with them. And this proves that on every level, whether it's atoms forming crystals or electrons forming arrangements around atoms, that everything has to do with matter simply filling holes. And whether it's electrons or atoms, it's all the same stuff. There are no forces to the electrons. The electrons don't attract magically to a proton at a distance, no. Then why does this attraction occur between a proton and an electron? And why does an electron approach the proton, and once it's done approaching the proton, it doesn't crash into the proton like you'd expect? Well, it's, again, like we were talking about with the electrons in the arrangement among the atom. These beads not only represent the electrons, but it represents the electrons and the buffers around the electrons. So the electron is approaching the proton. And see, here's the electron, here's the proton. The electron approaches the proton, but why? Why would the electron approach a proton? I mean, nothing attracts at a distance. There's no such thing. But that's not actually what's going on. The reason why the electron is approaching the proton is because what's around the electron is kind of like it's attracted to the electron, but it's not attracted to the electron. It's just filling holes about what's around the electron. Remember how we discussed gravity and how there's a lot of matter out there in the universe, but most of it's fine stuff. The large stuff wants to come together in order to cover the holes on the surface of larger objects. So this matter accumulates around the electron, and that matter out further, the stuff out further, it's thick, so it holds larger pieces from the matter universe as well. It forms a cloud of stuff around the electron. The same thing happens with the proton, but because it's much, much bigger, and of course this aspect ratio is, the ratio between, the electron and the proton, it's vastly larger than this. Obviously protons are much, much larger than electrons, and the distances are much, much further. But for simplicity's sake, we have these objects. And what's around the proton here, is much larger matter, because the proton can hold much larger matter in its area. And one of the pieces of matter that it holds in its area is the electron with its stuff. And what's happening is the cloud of what's around the electron here fits well with the pieces of the stuff that's around the proton. And so that's why, for example, in a hydrogen atom, like this one, you have one proton cloud filled with one electron's cloud. And so the electron will attract to it and then stop and kind of boing, 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 as the cloud just kind of goes. And, if it gets its electron ripped away, it'll eventually grab another electron and it'll keep it in its cloud. It'll bounce around until it kind of settles. And if it's very, very cold, it's not going to move very much at all until something, a wave or something bounces it, and then it might go around a little bit until it slows down and stops eventually. It can take a very long time for an electron to stop orbiting a nucleus. But you see, the reason that the electron goes around the proton, it's filling a space it's not like the Earth around the sun, where the Earth is staying away from the sun because of its orbit. No, electrons do not orbit nuclei. Now you see that picture in the Big Bang Theory, TV show with a bunch of protons, and you see a bunch of electrons whipping around it like this. That's not what's going on in real life at all. In real life, an atom is just like any other crystal structure where the electrons find a spot around the atom, and it doesn't orbit unless it's forced to, unless it's pushed by something. If it's pushed by something, it can orbit around it, and it can whip around it, but otherwise it's just there filling the holes. And it's about the filling of the holes, because see, this electron will stop advancing on this proton when the cloud of the electron fills the holes in the cloud around the proton. Why do they fit together so well? Because the electron's matter is finer than the proton's matter that's around it, and so the holes mesh together. It just kind of meshes together, and like you got the larger pieces and the small holes between them. And that's all you really need to know about electric attraction. That's why an electron will stop advancing on a proton. That's why it appears as though the electron is attracted to the nucleus, or to a proton, but it's actually not attracted to the proton. And that's why electrons don't crash into nucleuses, unless, again, like fusion, you can rough them up enough, like with heat or with pressure, with heat and pressure, and boom, you get a fusion between an electron and a proton, and then that's considered a neutron. But that takes heat and pressure to form a neutron using a proton and electron. Basically, the buffers around both keep each other apart. In fact, you can have repulsion between you do have a repulsion between an electron and a proton. If you push the electron in, it will spring away from the proton. They don't teach you that in schools, but yes, it does happen. And if it didn't, atomic collapse of all atoms would have happened, instantly, for all atoms, not just for hydrogen. There's a form of electric repulsion, and that is between, like, for example, two protons. They have the same material around them, and so when they crash up against each other's buffers, say there's a buffer around this proton because of the stuff that's remember, the matter universe has the larger stuff that fills the holes around larger stuff. So does this one. So when the two buffers come together, they push each other apart, because they're jamming up, like here's this guy's buffer around this guy, all the way around this guy, and here's this guy's buffer, and it's all right way around this guy. And whether this is these are two protons or two electrons, if you push them together, the clouds are pushing. It's pushing out the matter, and the matter wants to get back in. So the matter starts filling the holes back in between the two, starts filling the holes back in between the two, and that drives these two apart. It takes the matter that's around them, takes them away for the ride, and then just push each other apart. Same thing with two electrons, same thing with two protons, and that's simply electric repulsion. So what do we learn about electric attraction and electric repulsion? Well, we can see that they're both functions of the matter universe. Again, they're proof that the matter universe exists. And again, nothing repulses each other at a distance. Nothing attracts each other at a distance. it's all just matter directly filling the holes that they're falling right into because of the push of the matter universe. So it really all has to do with the pressure of the matter universe, again, as all things, as all push, as all action in the matter universe does. And again, proving that the matter universe, that is the ocean of matter that we are all in, surely exists. Next time we'll be talking about magnetic attraction, magnetic repulsion, which is diamagnetism, and the two forms of diamagnetism.